very charming good morning, a hearty warm welcome to our distinguished speaker of the day, Professor H.K. Sejwani sir. We are delighted to have Professor P.K. Aluwalia sir, the President IAPT, Professor Samantha, our ex-officio President Dr. O.P. Sharma, and all the other respected members of Executive Council of Indian Association of Physics Teachers, Regional Council 1, who are present over here, and my dear participants. Myself, Poonam Jain, your host and the Executive Council member of IAPT, welcome you all for the part 2 of the workshop on investigatory physics project using Arduino organized by IAPT RC1. Before beginning with the formal session for the day, this is to inform you that this session is being recorded and streaming live on YouTube and Facebook. Also, there is an important announcement for the participant. Kindly post your queries and questions related to the talk in the chat box so that our coordinator can consider them after the talk. Attendance form will be shared at the end of the session, filling of which is mandatory, then only you will be entitled for the certificate. Attendant link after the talk will not be shared personally on your WhatsApp group or the mails. So kindly fill it during the session only. All the participants are now kindly requested to mute their mic during the whole session for the smooth conduct. Without further ado, now I request Dr. Yogesh Kumar, the Secretary IAPT RC1, for welcome address and introduce our participants about IAPT. Over to you, sir.
Thank you, ma'am. Am I audible?
Yes, you are.
A warm welcome you all in the second lecture of Investigatory Physics Project using Arduino. On behalf of Yogesh Kumar, Secretary IAPT RC1, welcome our eminent speaker, Professor H.K. Sejwani. We are delighted with the presence of Professor P.K. Aluwalia, President IAPT, Professor Subhash Samanta, Professor C.K. Ghosh, and other distinguished professors present here. I welcome faculty from Delhi University, NCERT, school, colleges, universities like IITs, ISER, TIFR from different parts of India, member of IAPT, BSSTF, and all the participants. Also a warm and extended welcome to each and everyone who is here to mark their presence in this wonderful event. I also would like to tell about this organization. Indian Association of Physics Teachers, a major and well-reputed organization established by late Dr. D.P. Khandelwal in the year 1984, has a local chapter in every state. IAPT RC1 is a chapter of IAPT for Delhi and Haryana. We organize various activities for promotion of physics and physics education. In this pandemic, COVID-19, we have successfully conducted many important lectures for schools and college teachers and students. We appreciate your gesture. It is very generous of you to spare your valuable time with us. We are proud member of a family in which everyone is willing to share his or her knowledge and experience with others. With these words, on the behalf of entire physics fraternity, I welcome you all. I hope you will enjoy today's session on Arduino Part 2. Thank you so much. And over to Poonam ma'am.
Thank you, sir, for introducing our participants about IAPT. Now I request Dr. Seema Vats, the President IAPT RC1, to introduce our speaker of today's lecture. Over to you, ma'am.
Thank you, Poonam, and greetings to everyone on this auspicious day of Basant Panchami and Saraswati Puja on behalf of our whole team of IAPT RC1. We are blessed with the gracious presence of Professor P.K. Aluwalia, sir, IAPT President, Professor Subhash Samanta, C.K. Ghosh, sir, O.P. Sharma, sir. Sir, thanks so much for your gracious presence and motivating us. Now it gives me an immense pleasure to introduce our eminent speaker, Professor H.K. Sejwani, who is the former Dean, Academics at IIC College of Engineering and Technology, Greater Noida. He has been awarded with the most prestigious Man of the Year Award 2001 from American Biographical Institute. He has also bagged several academic and extracurricular activity medals. He has arranged various workshops on telescope, new practicals for CBSE curriculum, nanotechnology, and entrepreneurship camps for undergraduate and school students. His introduction would take the whole day, but I would say that not everyone can take up the challenges what Professor H.K. Shizwani sir has taken. To do that, he has to follow a recipe: hard work, dedication, and judgment. He has done that with passion, and now he is showing us way to unlock the Arduino projects to all the teachers and student community. We welcome you, sir. Kindly enrich us with a list of your endless experiments, but today we'll be covering, I think, 5 to 6 experiments. We welcome you, sir.
Thank you, सीमा जी. सबसे पहले वसंत पंचमी की सबको बधाई हो. 3 suggestions were there from Professor Aluwalia ji, Professor V.P. Srivastava ji, and Dr. O.P. Sharma. And I worked on those suggestions. Of course, Dr. Aluwalia wanted that there should be the competition on which our president Seema Vats is already working. Then Dr. V.P. Srivastava suggested that physical workshop should be held because learning by doing is the best way of learning the things. Then Dr. O.P. Sharma suggested that the project should be made which are useful for the society, environmental friendly, and innovative. Based upon his suggestion, I have already introduced one experiment in today's project. However, I will not be doing any spoon feeding today. I have already told you how to start the Arduino, how to install the Arduino, how to make a simple project of 3 LED blinking, and today's 7 to 8 experiments which I have planned. I will not be doing any spoon feeding, but each and every experiment has some basic concept, and those basic concepts I'll try to show you along with the actual experiment being performed. It is important to understand that some of the concepts may appear to be boring in the beginning, but they are actually not boring. You will learn a lot, as I think, and you will be able to understand many things with the help of which you should be able to make large number of the projects. So I'm sharing my screen now. Is my screen visible?
Yes, sir, it is visible.
Okay. So I'll do one thing more. Today is my part 2 of my investigatory physics of projects, and I have just shown a few experiment, the basics of which I'll be trying to make you understand. And I have arranged those experiments in this particular order. Determination of the G by measuring the time period using the IR sensor, and recording the data using the Teraterm, which is a free software, open source software. Then I shall be making you understand how to make your own functions. And for making your own functions, I have taken a very simple method or simple thing, and that is musical scale, sa re ga ma pa dha ni sa. Then I shall be explaining to you how, by just reversing the values of the pins from 0 to 1 and 1 to 0, you should be able to reverse the direction of the DC motors. And using the same thing, we shall be able to explain the law, which is called as a tangent law. Details I will tell at the time when I am showing this. Then the distance measurement using the ultrasonics. And its two applications I will be showing. One will be the application of parking, and another the application of the water tank, which was suggested by Dr. O.P. Sharma. Then I shall explain also, do the experiment of the interference of the sound waves, and then demo of the PWM pins. When in the last lecture, it was asked that what is the use of the PWM picture and PWM pins and how they are used, and I promise that I will explain it in my next lecture, and that is what I shall be doing today. And then finally, if the time permits, I will be showing you the experiment of the resonance experiment and some concepts involved in that resonance concept. So I first start with the determination of the G by measuring the time period of the using this. And before I shall be explaining to you the experiment, what I shall do is I will show you the working of that experiment. Is my screen? Oh, yes. You can see in this experiment, a simple pendulum is vibrating, and there is a IR. There is a IR here. This is a black one, and this is a white one. White one is not visible at the moment on the screen. See what is happening is on this side. On this side, there is a LED which is on and then off, on then off, on then off, and so on, so forth. What is happening is whenever the pendulum is coming before this IR, this is IR from this point to this point, this is IR, which I will show you later on also, separately also. So in the whenever simple pendulum is coming before this, what is happening is one of the LEDs, which is transmitting the light. It is falling on the simple pendulum, and then it is, after reflection, it is being taken up by this black the LED. Of course, it's not exactly LED, but one is transmitting the light and another is absorbing the light. You know that the black bodies are the best absorber. So this is the transmitting and this is LED. So as soon as this comes here, it counts 1, 2, 3, 4, 5. Every time you can see that this bulb is counting. On every counting, this bulb is glowing. Then it becomes off, then on. As whenever this pendulum will come in front of the simple pendulum, okay, this bulb will glow. And then after say 20 vibrations, 20 oscillations, that is 10 vibration, what will happen is that it will stop for some time, then again start counting, and that will be recorded on the main screen. I am again now say coming to my sharing of the screen, and this is the screen share. Now you can see that there are two methods of measuring the time period of the oscillating pendulum. One is using the IR sensor and another is the LDR sensor. Both these sensors are fixed on the same board, and therefore the same platform. And therefore I will be explaining only IR sensor and will be asking you to make the sensor using exactly the similar program to measure the time period using the LDR sensor. It will be exactly similar, but some logic has to be changed. So I'll be now taking up the IR sensor. I'll be loading the IR sensor. Why you not sharing? Where the sharing has gone? Oh. Yes. Now is the screen share visible?
Yes, sir.
Okay. So in this program, what we are doing is we are measuring the time. When the simple pendulum comes in front of the IR sensor, then it is the time has to be measured, and then again when it comes, then time has to be measured. The difference of the two will be calculated as the time period. So let us see. This is, we are defining certain thing. What we are doing is integer IR pin A0, analog pin. It has to, we are reading something with the help of this, and therefore it has to be connected to the, and the value may be fractional, because the time will be time can always be fractional, okay? Because in one oscillation, time may be 1.1 second or 1.2 second or 1.3 second, 1.32 seconds, etc., etc. Therefore, you have to measure the value, and this value is measured from the A0 pin, and then we are using LED pin. Actually, this LED pin is not required for this experiment. I can automatically read, but then we are using it to show that actually there is a measurement is going on, and the time is being measured. So we are defining an LED pin 9, and then we are defining a time T1. When the oscillation will start, it will be time T1, and when the oscillation stop, it will be time T2. And we have used 20 oscillations. See, I'm differentiating between the oscillation and the vibration. Oscillation will be from one extreme position to another extreme position, or from the mean position to extreme position and then again to the mean position. And vibration will be from the one extreme position to second extreme position and again back to the first position. So two oscillations will make one vibration, and that is what I am doing. Simple pendulum is coming in front of the IR twice. Since it is coming twice, therefore every time therefore our reading will be from one oscillation to another oscillation. Okay, then as you already know, and I have taken this pendulum. Actually this is this I have to change, and this I have to change. My length was 58 point something, 58.6. Somehow it has come to 58 point something. Okay, and then you, as I told you, that you have to define in the setup. You have to define what? You have to define whether the pin is an input pin or pin is an output pin. So what I'm doing is, now, since we are reading something from where? From A0 pin, and A0 pin is our IR pin, and therefore since we are reading it, therefore it will be input. Our pin mode will be an input and input one, and our LED pin, because it is giving you the light, therefore it will be considered as a output pin. Then we are giving you another concept here today, that is the serial dot begin. Till today, we have not till in the last lecture we have not shown you this serial monitor. Serial monitor we did not use. I am taking this my mouse to this right hand side, and you can see that this is a serial monitor. So we are introducing a concept of seeing whatever we want to see on our serial monitor, and for that there is a reserved word, and that is the serial dot begin. That means from here on, what will happen? On the serial monitor will start taking the reading and start showing the reading to you. So serial dot begin, and this is a baud rate of 9600. What is the meaning of the baud rate? Baud rate is how many bits are being sent per second. So a byte consists of the 8 bits, and therefore, and you can see that I'm asking it to transmit how many bits? 9,600 bits per second. After all, computer is based upon 0 and 1 concept. 0, 1, 0, 1, 0, 1. So bits. So every transmission is done in bits. Everything is transmitted in bits, and we are transmitting it at the rate of what? At the rate of 9,600 bits per second. There are many other rates which I will show you now when actually our program starts. So, and then we are giving it a delay of 2,000. 2,000 means 2 seconds. So then we are what we are doing on the serial monitor. We want to see something, and since we want to see something, therefore we are printing the serial dot print comma. Yeah, so comma will be printed first of all. Whatever is in the brackets, quotation mark, that will be printed as such. Then we are telling it the print the length. Then we are again giving this comma. Comma is used because I want to show you on the teraterm. If something is to be taken in the teraterm Excel sheet, then this every comma will take the next reading to the next cell. Of course, again I will explain to you at the end of this. Then you are printing time period, time for 10 vibration, printing time for time period, and then calculating the G, printing the G value. Whatever is in the quotation mark, you again see whatever is in the quotation mark, that will be printed as such on the screen. And this we have written in the void setup. This is your void setup. So, and anything that is written in the setup, it is executed only once. So this message, all this one message will come only once, and then we come to the void loop. Here is a logic for that. Logic for that is that we are defining a number, and we are giving it a value is equal to 0. So integer n is equal to 0, because every variable has to have some type. And since it will be increasing, n is equal to 1, 2, 3, 4, we are counting. We are not counting 1.1, 1.2, 1.3. Therefore, we are counting 1 oscillation, 2 oscillation, 3 oscillation, 4 oscillation, etc. And what is happening is that we are increasing the value of n is equal to 0 and to 1, 2, 3, 4, etc. Then we are doing the serial dot print comma. It has come here. Then serial dot print L. L is a variable which we have defined at the top. L is the length of the simple pendulum. Since we can always change the length of the simple pendulum, this pendulum has been suspended from a string at the top. Of course, that top is not visible. Yeah, but then you can see that L we have defined, and whatever we write down in the function, that is serial dot print is a function. You can see that there is an opening bracket, there is a closing bracket. And within the opening and closing bracket, we have not written L in the quotation mark. What we have done is we have written L only, and L is the value which has been defined earlier, variable which has earlier been defined. So it will be showing you the value of the L. Then while I am now saying it, while is a command, while is a loop, for next is a loop. Similarly, there are other looping statements, and when we are saying while this is happening, while n is less than equal to 0, because I have already told you that for 2 oscillation there will be 1 vibration. Therefore, if you want to count the number of the vibration, then and we are counting everything for the 10 vibration, and that means for the 20 oscillation. So if while n is less than equal to 20, whenever such thing comes, then a few things are written in a block. And block starts with the basic concept you should understand. The block starts with what? With the quotation with the curly bracket. And then while this is so, if digital read IR pin is equal to 0, IR pin is equal to 0. That means if IR is reading the value equal to 0, that means if no if this simple pendulum is in front of what? In front of our IR pin. Then what we have to do is digital IR is equal to 0. This is when IR pin is equal to 0. That means then the pin has to become high, because I want that at that time when the pendulum is in front of the IR, I want that the LED should be high. That means LED should glow. Then if is equal to 0, then n is equal to n plus 1. Whenever the pendulum will come in front of the IR, then what will happen? N will become equal to n plus 1. And if n is equal to 1, say first time if the pendulum has come in front of it, then we are using a function, again a function, you just see millis, and this is a bracket, opening bracket and closing bracket. Concept may seem to be difficult, but it is not difficult at all. If n is equal to 1, that means when first time the pendulum comes in front of the IR, then what I say is T1 is equal to millis bracket. What is the meaning of this millis? There are two functions. One is millis and another is micros. Micros will measure the time in microseconds, and millis will measure the time from millisecond. From when? Kab se? When we started the program, it starts measuring the time, and whatever time is available is there at the time at that particular time when n is equal to 1, that time is recorded in milliseconds. Once the time is recorded in millisecond, then what we say that serial dot print, what we say these are only the remark lines, so these are not executed. Then the delay is there for a particular time. That is, you have given up in the above. This delay we have defined above. Delay we have defined, and del is equal to 250. See, since whenever you want to make a program, a thinking has to be done. The bob has certain thickness. Since the bob has certain thickness, and as soon as the simple pendulum comes in front of the bob comes in front of the IR, what happens is the LED becomes on. But if we do not stop it, immediately, then for the width of the pendulum, the counting will continue, because you know that the light travels with the velocity of the light travels with the velocity 3 lakh kilometers per second. And therefore, going from the IR to simple pendulum and coming back to the simple coming back to IR will take hardly nanoseconds it will take, and therefore counting will continue. So we are as soon as our IR detects the pendulum, it should go away before the next counting starts. So that is why the delay function is there. Delay is there for this. And then what happens is, rest is very simple. Then if this is so, then n is equal to 1. And after that, once it is n is not equal to 1, after that it will go on counting. N is equal to 2, 3, 4, 5, 6, 7, 8, etc., etc. And then once all the 20 oscillations have been completed, because we said n is less than equal to 20. When n is less than equal to 20 and 20 oscillations are completed, that means 10 vibrations have been completed. What should happen is we should again measure the T2. First was T1, that was starting, and T2 is again millis. So whatever time has gone is there at that particular time, that will be called as a T2. And naturally T2 minus T1 will be the time period. So integer T is equal to T2 minus T1. It is the time in milliseconds for 10 vibration. And then we print it. Serial dot print is a T, then float time period is equal to T divided by 1000, because T is in what? T is in millisecond. So T into 10 raised to the power minus 3 means T divided by 1000. And then since it is for the 10 vibration, therefore we are dividing it by 10 to get the value of the time period. But you can see one very simple thing here, one very important thing rather here, that I have written dot after the 1000, dot after the 10. If you do not write down this dot, then what will happen? It will take it as an integer. And time period may not be integer. Time period will never be integer. It will be definitely a fraction. And therefore, dot means it is a decimal division. This is 10 dot is also a decimal division. And with the decimal division, you get the time period. And then finally, how do you define the value of the G? G is equal to 4 pi square into L divided by T square. 4 pi square into L divided. Pi is 4.3. 4 into 3.14, then 3.14, then L divided by time period. Of course, in another program, this value is given by another function. Serial print is this much. Serial dot print the value of the G and then delay of the 5000. After 20 vibrations have been done. So what I will do now is I will verify the program. So program is being verified. It is verified, and since everything appears in the white, therefore there is no error. And then I go to the tools. This is general procedure. You first verify, go to the tools and find out which board you are using. Tools. This board is our Arduino board. The board that I'm using is an Arduino board. And then there is a port. Port is, of course, you can see that port has not been selected here. We have to select the port, and I selected the port COM9. Again, see whether it is so or not. So this is port is COM9 and board is Arduino board. That is very true. And therefore now I will compile it. I will just upload it. So once I have uploaded, this is uploading. Now everything will come on the screen. See, 58.6 is the length that I gave, and it is now measuring the time period. See, it has calculated that the time for 20 oscillations was 15,457 milliseconds, and therefore time period for the vibration is coming out to be 1.55, and the value of the G is coming out to be equal to 967.31. In the meantime, the 20 more oscillations have taken place. 15,462, 1.55 again, 966.69. Why this difference when the time periods are same? Why this difference? 967.31, 966.69, when the time period is 1.55, 1.55. The difference is because you are measuring actually the values in milliseconds, and there is a difference of 5 milliseconds here. Since difference of the 5 milliseconds is there, therefore you can imagine how much is the accuracy. Accuracy is in 15,457 milliseconds, there is an error of only 5 milliseconds. And you can imagine how much is the accuracy of this value. This will continue, and the values will be shown here. But I want to show you that these values can be recorded very easily. So I am just closing it. And teraterm, yes. I want to start the teraterm. In the teraterm, I take the serial port, and you saw that the serial port was on COM9. Arduino COM9 serial port was there. So I say, okay, now I have selected serial, and instead of the TCP/IP, which of course you should know, and I am now logging the values. This file F, I log the values, and I give it name teraterm1.csv. It is in Excel sheet. In Excel sheet, there is a CSV file, which will be this records values will be recorded only CSV file, and this is the timestamp. At what time a particular value is being recorded, and then I save it. Whatever was happening, it was being saved, it was being recorded, and you can see that again. Oh, yeah, this has stopped. Yes, now it will be coming okay. We saw on the serial monitor that the value was 1.55 second for time period. Let us see whether we are getting the 1.55 time period or not. You can see, yes, you can see 15,465 milliseconds, then 1.55 second, and value of the G is coming out to be equal to 966.31. You can see that this value is nearly same as we are teaching the students. It is a 980 centimeter per second square. So this is again the value is coming out to be same. Again the value will come out to be same, and then I will stop this particular value. This is being recorded. Student is not doing anything. They have only started the experiment, and everything is being recorded automatically. I am now closing it. I am closing also the program. And to show you, screen sharing has been stopped as the shared window is closed.
Sir, we are not able to see the CSV file. I mean the data.
No, I will show you. Because it is saved on the desktop. So I'm. So I have to go to the desktop first of all. This is my desktop. Are you able to see the screen?
No, sir.
Yes.
Again, sharing has gone. Okay. Why sharing goes?
Sir, your experiment is visible. Your computer screen, I think you have not shared as yet.
Screen I will like to share. No?
Yeah, sure.
I will share this desktop. Now it is visible.
Yes, yes. Now it is visible, sir.
Okay. So I'm going to the desktop, and I told you that I am saving it with the name Terraterm1, and this is a CSV file. I'm just opening it. Once I open it, you saw that these two readings were recorded when our the simple pendulum was not observing the reading. So I just can delete this, delete.
Sir, the file is not visible. Only the desktop icons are visible.
Huh?
So there is a file named Terra Team 1, but after opening the file, the open file is not visible.
Why? When it is shared, so why should it not be visible?
I think you have to share that particular file again. After opening it, you have to share that particular
Wait,
file.
let me see.
Yes. You can click on that file only, sir.
Hmm?
This file.
Okay, let me see.
Sir, I am stop sharing your screen and now you share once again after opening the Terra Team 1 file.
Terraterm1. Okay. Now is it visible?
Yes, yes.
Yes, sir, absolutely visible.
Now it is
Okay,
open.
okay. So you can see that the Terraterm recorded itself, recorded the values, and I just gave it three readings were recorded, and these recorded are 58.6, 58.6, 58.6. Then these are the values in the milliseconds. Then these are the values in the time period. Now, once this has been recorded, what the student has to do is that he has to raise he or she has to raise the device in the forward direction, decrease the length of the simple pendulum, and then again take the reading. But reading will be taken automatically. They will be recorded automatically. Everything will be done automatically, and therefore the student has not to do anything. This is the beauty of this experiment, but the concepts involved are there. The concepts involved, so how can I make it big? I can close that file. Again, the save, and again I close it. If I close it, what will happen? Oh, it's not closing. Okay. Again, the screen has closed. Now, am I visible now? Yes.
Visible.
Yes, it is there. So I come again to my next experiment, and that is my share my screen again, and then it is the experiment. Yes, this is visible.
Yes, sir.
Oh, okay. So I from the current slide, I have done this, and then I come to the next experiment. Next experiment is again an experiment in which I'll be making you understand the concept of making your own on this functions on this function. You can see this program, this connection, very simple. What I've done is I've taken only one speaker. The speaker is not visible, okay, because I have not changed that camera. I'll be changing the camera to my own. You are able to see this speaker?
Yes, sir.
Is the speaker visible?
Can you bit closer?
Why full screen is not coming? Okay, because I have shared, yes. This way, this is visible or no?
Yes, sir, it's visible.
Yes.
This is the speaker, and you know that these speakers do not have any positive and negative. And since they do not have any positive and negative, what I have done is, in this screen you can see, we need only 2 points. Speaker is there. We need 2 points. One is the ground and another is the pin number 7. Of course, again, last time also I told you, it is not necessary that you choose the pin number 7. You may choose pin number 8. You may choose pin number 9. You may choose any pin number 6, 5, 4, 3, except 0 and 1, because they are the transmission lines and the receiver lines. These are transmitting pins. So these are the 2 pins only which you have to connect, and then it should produce the sound. Let me open this program. Why can't it open? What does it say? Where is the problem?
So you're not audible.
No, I'm not speaking as yet.
Okay.
I'm just trying to find out this. Where is my program? Yes, this is my program. Is the screen visible now?
Sir, you will have to close. You will have to close the sharing and then share that window again. Or if you can share the first that blue that screen which comes up when you go to share, that screen will come. In that case, even if you change the window in between, it will continue to share.
Today? Why this is happening today? This screen is not visible. That means
it is stuck at that motor, that PPT.
Okay. Oh, why this problem is coming today? It was not there yesterday.
So you can switch over to next experiment, which doesn't have any problem.
No, this is also not having any problem. But this,
Can you please stop
is
sharing
not
and
visible
then
to
again
You
share
stop.
the screen?
I have to close all these programs.
So you have to stop sharing and then share again.
Yes.
I am stopping sharing. I have stopped sharing.
Now go to share screen and then the first blue box. Tick that first blue box.
This one.
Yeah, the screen which says screen, the first one on the
Yes.
top left.
Yes. Why my screen is so small? I don't understand. Yesterday I did practice on this.
The screen is fine. I mean,
Yeah, now it will come, sir.
Now it is
Yes,
coming?
yes, sir.
yes, sir. Program is
Yes,
here.
sir. Perfect.
Okay. Anyway, I'm so sorry. See, in the diagram that I showed you, there was a speaker pin. Speaker was connected to the pin number 7. And in this program, I have not written anything else. The speaker has 2 points. One point is connected to the pin number 7. Other point, where should the other point should be connected? If nothing, if something has 2 points, then one point has to be given to a pin and another point has always to be given to the ground. This is one basic concept. Then, in collaboration with the musician, physicist developed a scale which is called as a musical scale. And in that musical scale, I don't know why this such an important thing has been removed from the syllabi nowadays, but this is one of the wonderful things which I think should be introduced again in the syllabus, and that was a musical scale. This is a collaboration between the musician and the physicist. They collaborated with the musician and created a certain range of the frequencies, certain values of the frequencies, and ask them whether this is musical or not. And we have a definition, definition of the music. If there is a regularity, there is no sudden change in the amplitude of the intensity of the sound, and then we call it as a music. Otherwise, if there is a sudden increase in the amplitude of the sound, certain frequencies are not matching with each other, then it is not a musical sound at all. So they defined certain frequencies, and those frequencies were between these successive frequencies, starting from the first frequency, which is called as a sa, then re, then ga, ma, pa, dha, ni, sa. Sa, re, ga, ma, pa, dha, ni, sa. You start with any frequency say 256. You see in your laboratories that you will always find out a tuning fork having a frequency 256. Then you will find out a tuning fork with having a frequency 280 something. I don't remember that because I have to calculate. But what they found was that in the successive intervals were 9 by 8, 10 by 9, 16 by 15, 9 by 8, 10 by 9, 10 by 9, 16 by 15, 9 by 8, and 16 by 15. If these are the intervals, intervals means between the successive ratio of the frequencies of the successive notes. Okay. Successive notes. So what is happening is, I defined, I see integer speaker pin is equal to 7 and del is equal to 1000. Float x is equal to POW 2, 1 by, oh, this I should make it. This is not desired. Integer 256, then integer re. For re, how much will be the frequency? Sa multiplied by 9 by 8. For ga, sa re ga, it will be re multiplied by 10 by 9. For ma, it will be ga multiplied by 16 by 15. And you know that you can give any name. In the musical scale, we know that it is sa re ga ma pa dha ni sa. In English, they call it C, D, E, F, G, etc., etc. But in our Indian language, it is sa, re, ga, ma, pa, dha, ni, sa. These are the successive frequencies. Now, since we have used only one pin, speaker pin is 7. Since we have used only one pin, therefore we have to define the pin mode in the word setup. This is your word setup. You have defined the pin mode. Speaker pin, output. Why output? Why not input? Answer is very simple, because we are to get the sound. The speaker will be giving out the sound, therefore it is an output device. Okay. Now again, now while loop. We don't have to show anything. We don't have to show frequencies. We don't have to do anything, and therefore no serial dot print is serial dot begin is there. So in the void loop, now this is a thing which you should try to understand. Once you understand, you will be able to make any function. What I'm doing is, see here, SA spelling is SA, SA, RE, GA, MA, PA, etc., etc. But when you come here, what I am doing is SAA, then REY, then GAA, MAA. The SA is SA, we have added one more letter here. RE, we have added one more letter here. GA, I have added one more letter here, and so on and so forth. What is here? What is this? Actually, this is a function. This is a function because you see it is left bracket and right bracket. But from where this function has come? It is not a standard function. It is not a result function. It is I who have defined this function. You can give it any name, but not the same name as has been given here. So so what I'm doing is I'm calling this function SAA. I'm calling this function REY. I'm calling this function GAA. Sa re ga ma pa dha ni sa, and then no tone, and then I'm giving it sa ni dha pa ma ga re sa. Sa re da ga ma pa dha ni sa ni dha pa ma ga re sa. I'm calling it, but I must have defined it. I must have defined a function which should be called from within this loop, and that is what I am doing now. You can see void setup, void loop, and these are my functions. This is void SA. Whatever I am calling, I am naming here void SA. For making any function, you have to write down void first of all, and then whatever function name that you want to give, that is SAA, and closing bracket, and then since void has to be defined, it has to be in some block. It has to be in some block, starting block and closing block. Then what sound is being produced? For that, there is a result function, and that function is our tone function. Sound is being produced. Some frequency is being produced. But tone is a result function, and we are saying it speaker pin, comma sa. Sa has some value. What was that value? 256. And then other re, ga, ma, etc. They were defined according to this musical scale, which was developed by the physicist in collaboration with the musician. So this tone, speaker pin was what? 7. And if you make the connection at the pin number 8, then the automatically speaker pin will be given the word 8. So Ray is what? Tone, speaker pin, Ray. This frequency has been defined. Ga, tone, speaker pin, ga, and so on. So we have defined all these functions from this point to this point. And for every function, after this tone is being produced, we have given the delay del. Delay del means that sound will be produced for this much milliseconds of the time. In above, you can see how much delay I have given. I have given the delay equal to 1000. Now, what are the connections? Only one connection. That is one end of the speaker to be connected to the 7, and then this program is to be written. In this program, we have made the functions, and how to write down the function, I have just told you how to write down the function. Yeah. Once you have done it, then I have to verify. I verify the program. Once I have done the compiling, then I again see I have to connect this is another Arduino board which I have taken. This Arduino board is not same as the Arduino Uno. This is a mega Arduino, mega, and I have three say Arduinos. One is Arduino Uno, another is Arduino Mini, and third one is the Arduino Mega. So since I'm using the various experiments for the, and I have used one board for one experiment, another board for the another experiment, so I'll be using this. Only thing is, whatever board you have, for that board you will be definitely having some pin. There are certain pins and there will be certain grounds. So I have certain grounds, and I showed you the let me now change the camera, change my camera. It's not coming. What has happened? Yes, it has come on there. Is it visible?
Yes, sir.
Oh, yes. So here is my this speaker. One pin has to be connected to the pin number 7. Another pin has to be connected to the ground. So here is a ground here. There are 3 grounds in this board, 3 grounds in Arduino Uno, and 3 grounds everywhere for every board. I will let you know how can we and take so many grounds or so many VCCs also. But currently I am using this board, and therefore I'll be connecting my this board to this board to you can now see I have connected this board to my Arduino, but Arduino Mega. So first of all I verify the program. Program is verified. Then I go to the tools, and you can see that the board written here is Arduino Uno, but this board is not Arduino Uno. This board is Mega board. So what I do is board is Mega. So Arduino Mega ADK is this board. Also, what about the port? Previously, the port was COM7 for the Arduino board. Now it is a COM6 for the Mega board. So I select this. Unless I select the proper board and proper port, the program will not be loaded. This is again the concept that you must keep in your mind. So now what I do is tools we have seen. Now we come to the uploading. I am now compiling. This is compiling the program, and then it will be uploading the program. Oh, why? What happened? It has been loaded and the sound is being produced. Perhaps you may not be able to hear much. Are you able to hear the sound?
Yes, sir, a little bit.
Little because there is a resistance of this is larger and the amplitude of the sound is very small. But you can see it is sa re ga ma pa dha ni sa. I will do a little change only on this, and that little change will be I will be changing the time of the delay. I will be making it say 500, and then again I will faster. Ma ga re sa re ga ma pa dha ni sa ni dha pa ma ga re sa. That is the and what we are doing, we are calling on. Simply we are calling it. You can from sa this function, and we have defined that function. Okay, so we now come to the next. Making the function is an important thing. Why we have used this void? Why we have used the void? No one asked from me. Yeah, the void is because if you are using the word void, then it will not return. It will not have to return anything. But if you do not use the void, then it has to return. The function has to return something. And since we do not want anything to be returned, therefore we are using the function void. Okay. So I just close down and then start with the next function. Next. Stop sharing. It is producing the sound. Okay, now I'll start with the another program. It is producing. Now this is visible.
Yes, sir.
Okay. Now running the two motors. This is visible now.
Yes, sir.
Cannot open. Why it is always saying cannot open? Is this program visible?
No, sir, your slides are visible.
Hmm?
Your slides are visible. You have to stop sharing and again share with the open program.
I don't know why this problem is coming today. Stop sharing and then share with this. Share with this which program?
Program window, sir, which you want to show.
Now?
Yes, sir, now it is visible.
Okay. So now another concept, running the DC motor. The concept is very, very simple. That you have a motor, you have two sides, it's a DC motor. Therefore, if you connect positive of the motor to one pin, and the negative of the motor to the another pin, what will happen? It will start rotating in one direction. And then if you just want to reverse the direction of the current, then what you have to do? You have to simply change the connections of the battery. Positive will be connected to the other side, negative will be connected to the other side. But can it be done directly and easily? Answer is very yes. We define two terminal T1, T2, T7, T2 as 9. Once we have defined T1 as 7, T2 as 9, and we give some delay function is 5000, and then we say void setup, because we are using two pins, therefore there will be pin mode will be T1 output, pin mode will be T2 output. I will not waste so much of the time on this. And now in the loop, what we are doing? We have to simply think what we want to do. What we want to do? We want that our motor should rotate first of all in one direction, then motor should rotate in the other direction. That is what we want to do. So how do we do that? Simply in this, we write down digital write T1 as high. Terminal T1 and terminal T2 are there. We are making terminal T1 as high and making terminal T2 as the low. What will happen? The current will start flowing from T1 to T2. And then we keep it rotating for certain amount of the time. And that time I have taken to be equal to 5000. Del we have taken to be 5000 means 5 seconds. So what will happen is in this motor will rotate till rotate for how much second? 5 seconds. Then digital write T1 low and T2 low, both are low, because I want, see, the concept of the physics is that when a motor is rotating, it will, and we stop want to change the direction, what will happen? Due to the inertia, motor will continue to rotate. And we do not want that it should rotate continuously, because the other direction rotation we shall not be able to see. So what we do? We now stop the motor by making it low. Then we are showing the digital write high. T1, T2 is high and T1 is low. First T1 was high and T2 was low. Now T2 is high and T1 is low. And then again both are low for 5 seconds. So for that I can show you that this is actually happening. This is my motor. I have to have two terminals only. I have two terminals. I'm changing the direction of the webcam. And I stop sharing. You have this arrangement? You are able to see? Are you able to see?
Yes, sir.
Okay. So what I want is terminal T1 was given the number 7. Terminal T2 was given the number 9. So I have taken this pin, there are 2 pins of this, and I'm connecting one to pin number 7, one to pin number 7, and another pin to the pin number 9. That's all. Nothing more is there to be done. And since I'm using the same board, therefore nothing has to be done. I'll simply this connection I have made, and you can very easily see that what connection I have made. So I will again share my share my screen. This is a motor, front motor. Where the program has gone. Where is it? And the motor. Okay. So since the same Arduino board is connected, therefore, oh no, I have to take different tool. Board is our ADK, and then the tool is port is COM6. COM6. I verify. And then I compile. Upload. And then again I stop sharing to show you that actually it is happening. Are you able to see what is happening today?
Yes, sir.
Are you able to see?
Yes, sir. Yes, sir.
Why I am not able to see? So you can see that pin is rotating in one direction.
Yes, sir.
Then it is stopping. And then pin starts rotating in the opposite direction. Have we done anything? Nothing. Simply I have interchanged the pin 7 and 9 through the program, and it is reversing. Now the same thing will be used, same pins will be used for our another program, and that is the tangent law. Let us see this tangent law. Why I am not able to see the screen? You are able to see the screen?
Yes, sir. It's very clear. You can explain the concept of tangent law.
Okay. So to me, it is not visible, but of course, if it is visible to you, just see this. Okay? What I am doing is I am taking these pins out from here, taking the pin out from here, and I connect these pins to the pin number 7 and 9. This is what I have made. This is a coil. Coil is rotated over.
थोड़ा सा और नीचे कर दीजिए. Yeah,
हाँ.
yeah. Now it's appropriate. Now you can explain. Yes.
Okay. This is a coil, and coil has two ends. One end is this, and another end is this. Okay. So we have to, and then there is a compass here. Okay. Once the compass is there, what is it visible now? Is it clearly visible?
Yes, sir. Yes, sir.
Okay. Now, compass. I rotate this compass in this direction, such that our needle points out towards the north and south. Points out towards the north and south. It is pointing out towards the north and the south. This is north-south. Is it okay? Now what is happening is this is pointing towards the north-south. So naturally the Earth's magnetic field is along this direction. And if I pass the current in this pins, current through these pins, then what will happen? What will happen? The magnetic field will be produced along the axis of the coil. And that magnetic field, since it is perpendicular to this north-south, therefore this will be produced in the perpendicular direction along the east-west. Okay. Now it is the simple law is that whenever a magnetic needle is suspended between the two uniform perpendicular fields, then the needle, magnetic needle or magnet, will rotate and come to rest in a position such that B upon H is equal to tangent theta. And therefore it is a matter of measuring the theta only. It is a matter of measuring the theta only. And theta can be measured if a student or the teacher who is performing this experiment is efficient enough, then I have given it 5 seconds for measuring this. And 5 seconds is more than sufficient time. It is 5 million microseconds. Instead of saying 5 seconds, I say it is 5 million microseconds, and 5 million microseconds is sufficient time to observe and take the reading. So what I am doing is, I am using the same pins, pin number 7 and pin number 9 of the same Arduino board, pin number 7, and pin number 9 of the same Arduino board. And you will see that what is happening is, since 7 and 9, they will interchanging their direction, isn't it? It was changing the direction of the motor. So now it is changing the direction of the current in the coil. So the same program is doing the two things. One is it is showing you how the DC can be the DC motor can be rotated reverse in the reverse direction without using the key. And another what it is showing is that it is. Good morning, sir. Tiwari ji, namaskar. So, are you able to see this? Are you able to see?
Yes, sir. Yes, sir.
So it is stopping here. Then it will be going to the other direction after 5 seconds. Yes, it has gone to other direction. Perhaps it was disturbed. Yes. Then it is coming to this. I can adjust again. I can take this out and adjust towards the north-south. Again, put this pin into this. And now it will be going equally on both the sides. It will be going equally on both the sides after 5 seconds. Now it is going to the left hand side or right? Come on. Oh, this pin has come out. It has gone to one side. Will come to the north south again, and it will go to the other side. Now, why I have shown this? Because every lab has got this device. Okay? And what you have to do is simply these two pins should be connected to that device. With that device, I will show you now. I'll show the screen sharing. Where is my this? Share. Go to the other side. This device you have. Every laboratory has this device in which there is a circular coil here. These two pins of the circular coils are connected to this point and this point. And simply what you have to do is these two pins of pin number 7 and pin number 9 are to be connected. They are this point and this point. So automatically, once this setting is done along the north-south direction, this is north-south direction, and this will be the east-west direction. That direction. Automatically, what will happen? The needle will go to this side. Needle will go to this side, and within 5 seconds, reading can be easily taken by the students or by the teacher, whatever the case may be. So therefore, tangent law can be by measuring the angle theta in one direction, measuring the angle theta in the other direction. You can always prove that B upon H is equal to tangent theta, and from that we can always find out the value of the H, because B will be equal to mu naught Ni divided by 2R. Mu is known to us, and the number of the turns on this is always given to us. Radius of this is always given to us. Okay? And therefore, by knowing the theta, we are able to calculate the value of that. Okay. Then the next, what happened? Why the screen has changed?
So we see your experiment screen.
You are able to see screen, huh?
Yes, this tangent law and the apparatus we are able to see.
So why my screen has changed?
You can just close it and then again share it.
Okay. Now the distance measurement. Before I do the distance measurement, I will show the program of the PWM. I'll show you the program of PWM. Let me show that. Is this program visible or no?
No, sir.
Again, I have to unshare.
Yes, sir.
I don't know why this program is showing this type of the thing.
So since this camera is on, I think you first explain all the pins and then you can move on to the program. because we are able to see the.
Okay, this is visible.
Yeah. So first you explain this and then you can move on to the.
Okay. See, you see that, and I've already shown you that in Arduino Uno or any Arduino board, there are certain pins with the tilde. There are certain pins with the tilde sign. I can show you on this the tilde sign, which I told you that these are the tilde sign. This sign is visible.
Yes,
Yes,
sir.
sir.
This sign is visible. Okay. So they are tilde sign, and whatever pins are with the tilde, they are the PWM pins. The other pins are the digital pins. Tilde pins can work as a digital pins also, but tilde pins are the PWM pins. If you want to use them as the tilde pins, if you want to use them as a digital, you can use them as a digital. But if you want to use them as the digital PWM, you can use them as the PWM, pulse width modulation. See, if for the digital, the values will be only 0 and 1. But for the PWM, we can give it any value, and therefore we can increase and decrease the intensity of the light. For this, I am now connecting it to my screen. Just see what is happening is this light is off. One light is off, and this is a digital pin. The other lights, you can see that slowly and steadily this intensity is decreasing, and then it is increasing. Once they have become a maximum, this also becomes maximum. Though this is a digital pin, other pins are the PWM pins. For PWM pins, you are increasing and decreasing the intensity of the light, but you cannot increase and decrease the intensity of the light of this pin, which is not a tilde pin, which is not a PWM pin. For the PWM pin, it will be either 0 or it will be 1. 0 or 1. In between values are there only for this. And value for this, you can see that the value intensity is increasing and decreasing. Let us see what is the program. Program is very simple. I just open it, and I then, again I will have to share them. Where do I? Big problem. Not able to see. What is happening? I don't know. Have I gone out of it?
So your apparatus is visible, and your
what
program screen is not visible.
program saying that is what I want to do.
Rajiv sir, can you help in this?
So we share screen करना है.
वो तो स्क्रीन ही नजर नहीं आ रही ना, मुझे वही नहीं नजर आ रहा. क्लोज विंडोज, क्लोज विंडोज, क्लोज विंडोज.
सर जूम वाली
Share
विंडो
your,
के अंदर, पहले जूम वाली विंडो में जाओ, तब उसके नीचे माउस लाओ.
जू वाली विंडो में जाकर मुझे जू ही नहीं दिखाई दे रहा.
हाँ, वो नीचे जब माउस को लाओगे ना, तब वो शेयर स्क्रीन का बटन पॉपअप हो जाएगा.
अब मैं एस्केप दबा कर देखूं शायद. Only you are visible. Oh. This is very surprising, and I'm very sorry for that.
So have you opened your file?
Now I will say this is PWM pin file. Okay. You can see that pin number 9, pin number 10, and pin number 11.
सर स्क्रीन शेयर सर.
Sir,
It is not
the screen is not visible.
Okay.
You have to share it once.
Okay. Yes.
Now it is visible.
No, sir. You just open this file once and then share screen. Then only the open file is visible to us. Otherwise, this folder name is visible.
Now.
Now, sir, have you opened that file?
Yes.
Now share the screen and share that particular file.
So when you click on the screen share, then many files are coming, right?
PWM file. This is the file.
Please click on that particular file. Yes.
Now this
Fine,
file
sir.
is visible.
Fine.
Now it is fine.
Okay.
Fine.
For the first time, this is producing so many problems. Huh? So now you just see pin number 9, 10, 11. If you see your this is Arduino board, then pin number 9, 10, and 11 are the PWM pins, and pin number 7 is not the PWM pin. And you saw that when what was happening was the velocity, the intensity was increasing, then intensity was decreasing. So what is happening is we have defined this LED Y as the 9 pin, LED green as the 10 pin, LED red as the 11 pin, and LED blue as the 7 pin number 7. So and then we have since we have defined four pins, therefore we have to give the pin mode to the all the four four pins, and all are output because they are giving you the light. So basic concept you must know that why do we call something as the input and why do we call something as the output? Because since they are giving the light, therefore it is a all output. Now what is we are again using a function, that is a for function. For integer I is equal to 0, I is less than equal to 255, I plus plus. This is a internal function, just as while was a function, do is function, and similarly there is a function which is called as a for function, and it starts with the initial value, then up to what value, and then how to increment it. Say I am saying integer I is equal to 0. I is equal to 0, therefore I will take a value is equal to 0. And then after semicolon, I am telling is I must be less than 255. And then I am increasing the value of the I by 1. I plus plus means I is equal to I plus 1. Yeah, the computer science teachers must be knowing what is the meaning of the I plus plus. I plus plus is nothing but the I is equal to I plus 1. So what is happening is initially value of the I will be equal to 0. Then it will continue till I becomes less than I is less than 255, and then every time it will go on increasing this. Once this is done, for this there is a block of the things that are to be done. And what is that? We are saying analog write what? Yellow as I is equal to initially 0. So then again we are saying digital write and LED GI delay. Then we are saying analog write LED RI. So every pin is getting the value I. Every pin is getting the value I, and we are writing as an analog write. Analog write. Remember, pins are digital pins, but what we are saying is you write down analog value from 0 to 255. Why 255? After finishing this, I will tell you. See, so what is happening is, then once this value of I has gone from 0 to 255, then this block is completed. So slowly and steadily, as I will become 2, then 2, then 2, 2 and 2, there will the analog write value will be 2, analog write value will be 2, then 3, then 4, then 5, then 6. And since the process is very fast and we are giving it delay of only 5 milliseconds, 5 milliseconds is not of course observable by us, and therefore it will go on. The next, what we are doing, once this block has finished, what we are doing is for I equal to 255, I less than, starting value is 255. We are giving it starting value as 255. Then we are increasing we are telling it continue to decrease this value till I is greater than 0. So from 0 to 255 it is increasing. From 255 to 0 it is decreasing, and therefore what is happening is that we are getting increasing value of the intensity and then decreasing value of the intensity here. But what is happening to the blue? Although we are writing down analog for the blue, therefore what is happening is, and this it will not be accepting the analog because it is not a PWM pin. It is not accepting the analog. However, it becomes on once when the value comes to be 255. As soon as the value comes to be 255, anywhere in between, it is not on. So for the value 255, it is on, because 255 means highest voltage, and that is 1. 0 means 0, 255 means here 1. So you saw that it was increasing, then decreasing, increasing, and then decreasing. Value was increasing and decreasing. Of course, you continuously it is happening. So this is becoming high. When it is becoming high? When the value is 255. When it is becoming what is happening here? It is decreasing. This is 1 to 2 PWM program. Okay. Now I unshare, stop sharing again, and then open another program. So of the PWM also again. Oh. Now you are able to see this program?
Yes, sir.
Yes, sir.
Okay. Now this is another program of the PWM, pulse width modulation. what is happening here is we are defining a red LED as 7, yellow LED as 9, and the green LED as this, and blue LED as 11. The same values, same pins we are using. So same program will be there. Same connections will be there. Connections will not change. But then what is happening is you are taking a potentiometer. Besides these 4 pins, you are taking a potentiometer, and we are defining that pot pin as A0. With the potentiometer, you are able to change the values. With the potentiometer, you are able to change the voltage. And that pin has to be connected to the since it has to be read, whatever value is coming with the help of the potentiometer, we are changing the value, and it has to read that value. Therefore, it has to be input. So what we are doing is, here in the pin mode, all the pin mode, red LED, yellow LED, here we have given different names, but it makes no difference at all. Whatever name you give, it is the pin numbers which are important, which is the pin number which are important. Now you see that the serial dot begin baud rate, we will like to see the values shown by the rheostat. Then what we are doing is, this is while loop. This part you can just see. In voltage is coming from where? It is coming from the rheostat. This value is coming from the rheostat. It is analog read pot pin. Pot pin we have defined as a potentiometer pin. Analog read pot pin, because it is A0 is a analog pin. We are reading there, and that value is stored in the in voltage. Then out voltage we are calculating. Here is another concept which I want to tell you. Very, very important concept. If you really want to make good programs, then try to understand this mapping. This is map. It has taken the input value. It has read the value. The potentiometer has read the value. And then we are calculating the output voltage will be equal to what? This is the value which we want to give to the digital pins or PWM pins. Analog out voltage is equal to map what? Map the whatever value has been read by the potentiometer. Map out map in voltage from 0 to 1023 and 0 to 255. Try to understand it. And this will be used in large number of the program. And that is why I said that every program will have some different concept. Actually, analog pin use the 10-bit 10-bit operation, and the digital pins of this use the 8-bit operation. 8-bit operation means 2 raised to power 8, and 2 raised to power 8 means 256, and from 0 to 255 it is 256 values. What about the analog pins? Analog pins work on the principle of the 10 digits. 10 bits, and 2 raised to power 10 means what? 2 raised to power 10 means 1024. And since 0 is also there, so from 0 to 1023, whenever you will be using a rheostat or any or LDR, etc., the values that you will get will be values from 0 to 1023. And on the output, what you will be getting the values that will be between 0 and 0 to 255. 0 to 255. Therefore, if on the analog pin value is 0, on the digital pin value, on the PWM pin, the value is also equal to 0. If it is equal to 1023, then on the digital pin it is going to be 250, 255. Therefore, mapping has to be done. From analog pin, we are going to the digital pins. From analog pins, we are going to the digital pins. Therefore, if this is 0, this is 0. If this is 10223, then this is 255. And if it is say somewhere in between, then it will be values will be somewhere between this. मैं दोबारा से इसको एक्सप्लेन कर रहा हूँ. डिजिटल पिन जो है वो 0 से 255 तक है, क्योंकि वहां पर हमारे पास 8 बिट ऑपरेशन होती है, और जो एनालॉग पिन्स है वहां पर हमारे पास 10 बिट ऑपरेशन होती है. और 10 बिट ऑपरेशन का मतलब है 2 into 10 raised to power 10, जो कि 0 से लेकर 1024 तक होती है. और जो डिजिटल पिन्स होती हैं उनकी जो ऑपरेशन है वो 8 बिट ऑपरेशन है. 8 बिट ऑपरेशन का मतलब है 2 raised to power 8, और 2 raised to power 8 का मतलब है 256, और 256 में अगर 0 करें तो 0 से लेकर 255 तक. अगर यहाँ पर वैल्यू 1023 के बीच में वैल्यू आती है, जैसे हमारे पास ये हो गया 1024 512, अगर हमारा जो पॉट पिन है वो 512 रीड कर रहा है, तो यहाँ पर हमारे पास कितना आएगा? 128 आएगा. अगर पॉट पिन हमारे पास 1023 का रीड कर रहा है, तो यहाँ पर हमारे पास क्या आएगा? 255 आएगा. इसका मतलब है जो आपने इनपुट वोल्टेज ली है एनालॉग पिन में, उसको आप ट्रांसफर कहाँ पर कर रहे हैं? उसको आप ट्रांसफर कर रहे हैं ऑन दी डिजिटल पिन्स ऑन ऑल द पिन. और जब हमारे पास ये मैपिंग हो गई तो हम एनालॉग राइट करते हैं. एनालॉग राइट काम पर करते हैं, बोला रेड एलईडी पर आउटपुट वोल्टेज डाल देते हैं. तो हमारे पास ये कौन सा है बोला? हाँ, ये वो है. हाँ, पिन नंबर 7 जो है वो डिजिटल नहीं है, और आप देख रहे हैं ये मैंने देखिए स्लैश है, स्टार है, और यहाँ पर हमारे पास स्टार है, स्लैश है. स्लैश स्टार और स्टार स्लैश के बीच में जो भी वैल्यू जो भी कुछ लिखा होता है वो हमारे पास कमेंट पोर्शन होता है. तो हमारे पास ये चीजें एग्जीक्यूट नहीं होगी. तो हमने कहाँ रखा? एलईडी पर हमने आउटपुट वोल्टेज दे दी, येलो पिन पर भी हमने आउटपुट वोल्टेज दे दी, ग्रीन पर भी हमने आउटपुट वोल्टेज दे दी, और ब्लू पर भी हमने आउटपुट वोल्टेज दे दी. सब जगह पर हमने आउटपुट वोल्टेज दे दिया मैपिंग करने के बाद. और मैपिंग किस वजह कहाँ से हो रही है? हमारे पास इस रियोस्टेट से हो रही है. सो आई विल नाउ अगेन, आपको ये दिखाई दे रहा है ना? ये दिखाई दे रहा है कंप्लीटली. हाँ, पर मैं इसको अब शेयरिंग खत्म कर रहा हूँ और इसको मैं वर्किंग दिखा रहा हूँ.
Yes.
हाँ, so I stop sharing and now this is visible to you clearly. ठीक है, दिखाई दे रहा है? It takes some time, I think.
Sir, it's visible, and I think after this we can wind up the session for today because it's already 1, and we have questions answer session as well.
Okay, then I'll do that. You just see now, I'm changing this rheostat value. Their intensity is changing. And then when I change this, again the intensity is changing. This goes off, but their intensity is decreasing. This goes on, intensity is maximum, but this goes off and their intensity will be changing. So rheostat is able to change the intensity. I wanted to show, of course, the another, but since time is too short, and it is because there were so many times there was glitches in opening the programs. Anyway, so thank you very much. Thanks everyone. And if there are any questions, I am ready to answer those questions. So I'll again change my camera to myself.
Thank you so much, sir, for showing us such a vibrant explanation of all the experiments.
But I am extremely sorry that so many times I could not join various.
No problem, sir. No
No problem, sir.
Okay, no problem.
Now the session is open for questions from participants, and I request Mr. Surjan Singh, the Vice President of IAPT RC1, to conduct the question answer session. Sir, since already we are running a little late, so, and I think
Yeah.
A lot of questions are there in the chat box, so kindly take only those questions which are relevant.
Okay.
You, sir.
Thank you, everyone. Good afternoon, all. Sir, actually, there are few questions only. So, Dr. Rajiv Tyagi,
Okay.
he had raised first question. He wants to ask the introduction of Terra term because he has never used this Terra term.
Yes.
So please guide.
Terraterm is a open source program in which from which you can capture the values which are shown on the screen, and therefore once you download this Terraterm software, it is transferring the values from the Arduino to the CSV file. There are two things. One is TCP/IP, which is a normal transfer protocol, which is used for the Google, etc. Everything. But and another is the one we used for our Arduino serial port. There was a serial monitor. On the serial monitor, we see some values. From the serial monitor, it has to be closed. It will come to the serial port. When we use the Terraterm, you can download it and it is free. Terraterm can be downloaded. It is free. Once you have downloaded it, then you can run it. Okay? And whatever values you are getting on Arduino board, those values will be transferred to your CSV file. Yeah. But CSV file, they say file name while logging, the file name has to be given the extension of CSV. Unless the file name is given the extension of CSV, the values recorded will not be shown by you.
Okay, thank you, sir, for this. I think, Rajiv, sir, it is clear to you. Now, another question is raised from his side only. Sir, actually, this was his concern, basically. Which speaker is being used? Because mine is producing the same note for all frequencies.
सर वो काम चल गया फिर वो
अच्छा, वो हो गया था, that was done.
आवाज ऐसी नहीं आ रही जैसे सहजवानी सर के वाले की स्पीकर की बड़ी मीठी आवाज आ रही थी ना, हमारे वाले की कड़वी आवाज आ रही थी.
That was brilliantly done. Okay.
वो ऐसा है
हाँ
कि हमारे जो स्पीकर हैं उनकी फ्रीक्वेंसी बहुत कम है, नहीं उसकी सॉरी जो एम्पलीट्यूड जो है वो बहुत कम है, इस वजह से साउंड बहुत कम आ रहा था. उस प्रॉब्लम को रिमूव करने के लिए फिर मैंने एक ट्रांजिस्टर का यूज किया था, ठीक है, जो मैं आज दिखा नहीं पाया. जब अगली वो जो होगी, जो प्रोग्राम होगा, जो उस प्रोग्राम में मैं डेफिनेटली उसको दिखा पाऊंगा, क्योंकि ये इलेक्ट्रॉनिक्स पोर्शन है. आउटपुट ऑफ आवर दिस हैज टू बी गिवन टू सम एम्पलीफायर, ठीक है, एंड देयर इज ए वेरी स्मॉल ट्रांजिस्टर विद द हेल्प ऑफ व्हिच वी कैन डू. हम बड़े आराम से कर सकते हैं. मैंने किया था, पर आज मेरे पास टाइम बहुत कम था और दूसरे ग्लिचेस भी आए थे कुछ, ठीक है, नहीं तो मैं बहुत ही और 2-3 प्रोग्राम मैं दिखाना चाहता था. एनीवे, बट एम्पलीट्यूड इज स्मॉल और दैट इज द ओनली प्रॉब्लम.
Okay, sir. There's one more question from Tripti Vaksi. What all programming languages are suitable for working on Arduino other than C or C++? I think this is Python.
Yes, Python can also be used with this Arduino boards, you know, and this its own IDE is now being developed more and more, and it is now being given on the cloud also. So you will be able to make certain programs on the cloud also with the help of this. But then you will have to work hard to be accustomed with the cloud computing. Okay. Besides C, there are many other languages which Java can be used. The other scripts can also be used, but the best is our Python.
Okay, sir. One last question, I think. This is from Chandra Raj, and is that we can change these programs to work the microcontroller instead of Arduino?
Yes, any microcontroller can be used. See, I showed you 3 microcontroller. One is Arduino Mega, another is Arduino Mini, and the third one is another one is this. But then there are other microcontrollers are available. Any microcontroller you choose, there will be certain pins, and those pins it's not necessary that it will be 0, 1, 2. It can be written as PD0, PD1, PD2, PD3, etc., etc. And if they have say pins, well-defined pins, well-defined grounds, well-defined VCCs, etc., then any microcontroller can be used for this.
Okay, thank you very much, sir. Remaining actually participants are writing this wonderful. This was a wonderful session organized by Sajwani sir. So we are grateful to them. They are writing and they are appreciating our work. And sir, hats off you because of for this wonderful session. And I think time doesn't permit us to for more questions. So I think thank you everyone. And now over to you, ma'am, Poonam ma'am.
Thank you, sir. Now I would like to request Professor Ahluwalia to give some concluding remarks about the 2-day workshop on investigatory physics project using Arduino. Over to you, sir.
So thank you very much, Poonam ji. Good afternoon to everybody, and a happy Basant Panchami. And I think, it seems that it is going to continue, because this is not the end of what Professor Sajwani was interested in talking. So we will keep on looking forward to more such sessions. And I believe that this has been a wonderful start to a wonderful open source hardware and software. I really enjoyed it. And that is the reason that I could stay till the end. So that shows the skill of Professor Sajwani also, that despite that the distant mode, he could keep the audience glued to their PCs, and maybe some have got the hardware also to work on these things simultaneously. So I think this is great thing. I just would like to say one thing more, that if you are thinking of planning some kind of a short-term course on it, maybe there should be a focus on one or two things in the beginning, particularly regarding the costing of the Arduino lab. If it can be provided, that will encourage people to look forward to some kind of a money to have that in their institutions itself. That is one. Second is some kind of an exposure to the keywords and the specifications in terms of specifications and keyword sheets. It is just like cheat sheets which you can provide to the people, so that whenever they have to refer to something, they will be able to refer to those things at a glance. That will be my second request. And if that can be done, I think your sessions can become very, very fruitful, and people will have something to carry with them for future also. The third thing which is there is, I think this is a wonderful way of introducing things, but somehow or the other, there is always black box kind of feeling which stays with the people when they try to explore such boards. If that kind of a mystery can be further taken care of, I think that will be wonderful. Otherwise, many a times people really get put off when they have to do these kinds of experiments, because they always see various things sitting on the board as black boxes. And I think that will be the desirable part of it. So these are my just suggestions. And I think I would love to see more of your such programs in near future. and great going for RC01 IAPT. All the members of RC01, they deserve a big applaud for taking this initiative and showing other RCs also that how things can be managed so effectively. So thank you very much, the President RC01, Professor Sejwani sir, all the office bearers, and the respected participants who joined from all across the country. Thank you once again.
Thank you very much, sir.
Now I request Shri R.K. Tiwari to give some feedback regarding this workshop.
नमस्कार सभी को। और
नमस्कार सर।
मैं तो पहले माफी मांग लूं क्योंकि आज बहुत लेट मैं जुड़ पाया हूं इससे, और चूंकि स्कूल के काम में बिजी था, बजट वगैरह बनाना था, तो करीब 12:30 के करीब में जुड़ा। लेकिन सहजवानी सर का तो आप जानते ही हैं कि सहजवानी सर बहुत अच्छे तरीके से हर चीज को समझाने की कोशिश करते हैं और बहुत ही सहज तरीके से वो करते हैं। तो मैं आशा करता हूं, अभी जब सर बोल रहे थे तो मेरे मन में विचार आया कि अब तो सब कुछ खुल गया है और DDMA ने भी सबको खोल दिया है, तो क्यों ना एक वर्कशॉप हम अपने DAV दरियागंज में कर लेते हैं ऑफलाइन। और ये हमारा सौभाग्य होगा कि सहजवानी सर अपने जो हैंड्स ऑन एक्टिविटीज हैं वो हमारे टीचर्स को और बच्चों को हमारे यहाँ करा दें। एंड आई विल अरेंज all these things.
Thanks so much, sir.
सर,
Thank you, sir.
एक चीज मैं कहना चाहता हूँ सर कि
बहुत बहुत धन्यवाद।
मेरे पास 20 टीचर्स की कॉरेस्पॉन्डिंग अपरेटस अवेलेबल है, इसीलिए स्कूल को एक पैसा भी खर्च न करना नहीं पड़ेगा अगर 20 टीचर्स का वो वर्कशॉप कराते हैं तो। इनिशियली आपको कुछ खर्च करने की जरूरत नहीं है, एवरीथिंग इज अवेलेबल विद मी। मैं डेफिनेटली अगर आप बुलाएंगे तो मैं डेफिनेटली आऊंगा, ठीक है ना। और आपके टीचर्स को मैं हैंड्स ऑन सारी चीजें करके दिखा सकता हूँ।
सर आपका विद्यालय है?
हाँ जी सर।
सर आपका ही विद्यालय है?
हाँ ठीक है।
अच्छा, धन्यवाद, बहुत बहुत धन्यवाद आपका कि मुझे आपने चांस।
Yes, sir. It's a great pleasure. We have the resource person, we have the venue. Everything is ready with the Sejwani sir, and R.K. Tiwari sir is going to give us the venue. So it's very easy for us to now arrange everything.
Just one intervention for us for 2 seconds.
Sure,
this is Dr. C.K. Ghosh from Kolkata. I was really spellbound listening to this lecture. There were glitches, never mind, but you have generated tremendous interest. And we would also like to join, but I am in Kolkata. It's nice that a workshop is going to be held at a school in Delhi, but just remember that I am in Kolkata. In any case, I was, jokes apart, we welcome such a workshop, and I'm definite that it would be a great occasion with such enthusiasm generated by Professor Sejwani. Thank you.
Thank you so much, sir, for kind words.
Thank you, sir. I request you to please switch on your video if possible.
Yes, sir is here.
Thank you, sir.
Thank you, sir. We are not able to see you. Only the roof ceiling is visible. No problem. Now.
Yes.
Now, at the end, I request Dr. S.K. Singhal, the treasurer of PTRC1, to propose vote of thanks. Over to you, Singhal, sir.
Thank you, पूनम मैम। सबसे पहले मैं सभी को आज बसंत पंचमी की हार्दिक शुभकामनाएं। मेरी ये प्रार्थना है कि माँ सरस्वती की कृपा हम सभी पर बनी रहे। आज बहुत ही अच्छा दिन है। हमारी प्रेसिडेंट सीमा वस मैम सेक्रेटरी योगेश जी, आप देख सकते हैं कि पीले वस्त्रों में है इस बसंत पंचमी में, तो ये एक सौभाग्य है हम ही सभी का। तो वेरी गुड आफ्टरनून टू वन एंड ऑल प्रेजेंट टुडे. First of all, I would like to thank Honorable Professor P.K. Ahluwalia sir, National President IAPT, Professor Rekha Gorpade, General Secretary, Professor Subhas Samanta, Professor C.K. Ghosh, Dr. O.P. Sharma, Dr. Seema Vats, President IAPT RC1 Delhi Haryana, Dr. B.P. Tyagi, all respected guests, IPT members, and all participants. It is my privilege to have been asked to propose the vote of thanks for this great occasion in a webinar of Professor S.K. Sejwani sir. I, Dr. S.K. Singhal, Treasurer IPT RC1, Delhi Haryana, on behalf of IPT RC1 entire team and on my own behalf, express a very hearty vote of thanks to all speakers for gracing your important work and sharing with your valuable finding and research. A big thank to Professor P.K. Ahluwalia sir and Professor Rekha Gorpade ma'am. I must mention my deep sense of appreciation for Professor H.K. Sejwani sir, who explained this investigatory project using Arduino in a very simple way, and that simple way that everybody can understand, even that many of us do not know about this programming C++, Python, but his way of explaining all these things are very simple. So thank you, sir, for this, for your effort, for explaining this Arduino programming and Arduino project to everyone in a very simple way. I would like to thank I would like to thank all our great visionary, great past presidents, Professor V.K. Srivastava sir, Dr. O.P. Sharma sir, for their remarkable contribution to lift the level of IAPT RC1 to this present level. Their work cannot be forget by all of us, because with their effort only the IAPT RC1 is known in all RC on IAPT RC nowadays. I also extend my thanks to Dr. Mohan Singh Bhandari, Dr. R.K. Tiwari sir, Jaiveer Singh ji, Dr. Ravi Bhattacharya ji, Mrs. Ramik Kapoor ma'am, Rajiv Tyagi ji, and other members of the previous executive committee of IAPT for their innovative and valuable contribution in achieving the milestone and the dedicated efforts. I would like to express my gratitude to the present president, Dr. Seema Vats ma'am, for her great vision and organizing such a wonderful workshop, wonderful webinar of Arduino, investigatory project by Arduino. And she has a great vision for the future to organize more webinar of such kind. She already expressed this thing to all of us. In future, many new webinars will be organized. She always think to lift the level and the teaching and knowledge of all physics teachers of school and colleges. I would like to thank our present secretary, Dr. Yogesh Kumar sir, our vice president, Surjit Singh sir, and our other executive members, Dr. Poonam Jain ma'am, who hosted this program very wonderful every time. She always present this program. Dr. H.K. Sejwani sir, Dr. Ajay Garg sir, Dr. Manoj Kaushik sir, Mr. Vikas Mittal, all IAPT members. At the end, but not the least, I would like to express my gratitude for distinguished professors, faculty members from Delhi and other universities, schools, NCRT, IITs, members of DSSTF, And once again, I would like to thank to each and everyone present today for attending this workshop. Thanks.
Thank you, sir. So today's event, again, a resounding success, has approached its completion. Before signing off, I once again thank the speaker for enlightening the audience with his wide knowledge about physics project using Arduino. Heartfelt thanks to Professor Ahluwalia for his views about the workshop. Heartfelt gratitude to all the other distinguished guests for showing interest in the event and giving us their time. Also, this event is not completed without mentioning a big gratitude to our participants for making it a great success. Attendance link is already being shared in the chat box. Filling of attendance form is mandatory so that you can get your certificate within a week time. Attendance link will not be shared on a personal basis after this workshop, so kindly fill it during the session. Thank you all for joining us. Thank you everyone for being a part of this lecture. We appreciate everyone's presence in this event. Thank you everyone. Stay home, stay safe, more on, stay connected. I think I should switch off this meeting now.
Yeah, sure. Poonam. Okay.
Thank you everyone.
Thank you everyone.
Thank you.
Thank you. सबको शुभकामनाएं.
Yes, thank you everyone. Thank you, Sajwani sir.
Thank you, sir. Thank you.
This was a wonderful session.
Thank you, sir. And
Okay,
thank
ma'am.
you.
Okay, Seema ma'am. Yogesh,
Whole team
Thank
of
you, sir.
RCT.
Poonam ma'am,
Thank
Kinga
you.
sir. Thank you very much.
Thank you.
Thanks for your efforts. The efforts which you are putting off.
No, sir, it's the teamwork. I always believe in teamwork.
ठीक है, but टीम वर्क तो होता है. कुछ तो टीम में ऐसे मेंबर होते हैं जो खाली रहते ही हैं. टीम में है, नाम के होते हैं टीम में, बाकी करते तो कुछ ही लोग काम है.
ये टीम बहुत अच्छी है.
ये सर, ये सबका एफर्ट है.
बहुत अच्छी रही है टीम.
तभी हम यहाँ तक पहुँच पाए हैं.
हाँ, तो अब ये यंग टीम जो है ना, वो वंडरफुल.
थैंक यू.
सबसे यंग तो आप ही हैं टीम में. सजवानी सर,
हाँ जी सर,
आपकी डायरेक्शन में हम लोग काम कर रहे हैं.
बिल्कुल.
Yes, absolutely, sir.
सामाजिक डायरेक्शन में काम कर रहे हैं.
I don't have any direction. I just flow.
चलिए हम सब.
चलिए मैम.
Thank you sir. Thank you.
Okay, thank you
Okay,
everyone.
bye.